Hi everyone, bonjour. The IB Crocodile is here. Welcome to my YouTube channel. Today I'm going to start the first question or one of the first questions in Physics May 2023 session, just last year. And I will go walk over the problem and show you the solution of this question. We can solve together. We can think together about how to solve this question. So this is physics standard level, paper 1, time zone 1, May 2023, number 4. The same question appears as number 5 in higher level in HL paper in the same year, in the same session, May 2023. So let's see. A car accelerates uniformly. The car passes point X at time t1 with velocity v1 and point Y at time t2 with velocity v2. Okay, so at point X here, okay, we have certain time t1 here, and at point Y you have another time t2, but then here v1 and this is v2, and then we see here a keyword here, accelerates uniformly, and also I can see this is a motion in a straight line. So basically, the question is telling me the two conditions of using the kinematic equations of motion are met. So what are these two conditions? Uniform acceleration and motion in a straight line. So the following expressions are proposed for the magnitude of its acceleration A, and we've got here some expressions, and we need to see which one is correct. Okay, so obviously we need to use the kinematic, or we call it the SUVAT equations, right? Which is down here. I got it here for you. Of course, it is in your booklet. So what we need here is to express A. You use the expressions or the formulas or the equations, having the acceleration, and try to separate for A. So, the V here is the final velocity, which we call it here V2. U is the initial velocity, which is here v1, and t here is basically the time interval, the time of the motion itself, the time of the change in velocity. So basically t here is basically delta t. We can actually express here t as delta t, which is t2 minus t1. So let's use the first equation here. So let me just change the color here, just to let me go back to black. Okay, so what we can do here, so the first equation, we can say v1 is equals to u1, v1, because now u, is basically v1, and v is the final velocity, which is v2, right? So v2 equals to v1 plus a times delta t. And now basically I can say, delta t is t2 minus t1. Right? So you can say, v2 minus v1 equals a multiplied by t2 minus t1, right? And that implies you can separate for a, which is v2 minus v1 divided by t2 minus t1, which is basically the definition of acceleration, rate of change of velocity. And you can see here we got this equation here down as number 3. Now, if we use the second equation here, S equal ut plus half at squared, right? Now S here is S, this is just the displacement traveled, right? And then equals to ut. Now u is going to be the initial velocity. Now the question called it v1. Now t is going to be delta t again. It's not, so t2 minus t1. And then plus 1/2 times a multiplied by t2 minus t1 all to the power of 2. If you multiply everything by 2, just to deal with this fraction here, so it's gonna be 2s is 2 times v1 multiplied by t1 minus t2 plus 2 times half, which is a t2 minus t1 squared. Now you can shift this term to the other side with negative sign, right? So it's going to be 2s minus 2v1 multiplied by t2 minus t1 plus and that's basically equals to A times T2 minus T1 all to the power of 2, right? I just shifted this term here to the other side with negative sign. Now I can separate for A or make A the subject. So A is going to be, the full term on the left-hand side divided by the coefficient or whatever term multiplied by A. So, okay, so it's going to be 2S minus 2V1 multiplied by T2 minus T1, which is delta T, over T2 minus T1 all to the power of 2. Okay, obviously this formula here is not there. So we have something like similar here, but of course it is wrong. So one most likely it is the wrong expression here because it doesn't match, this one here. So then we can continue now solving for A in the third equation. So what we've got here, we've got V squared equals to U squared plus 2AS. Now the third equation now. So instead of V, I'm going to call it V2. And instead of U, I'm going to call it V1. So V1 squared plus 2A multiplied by S, which means V2 squared minus V1 squared equals to 2AS. Now, if you make A the subject, so you will end up with V2 squared minus V1 squared over 2 times S, right? Which is actually number 2 here. So basically the final answer here, 2 and 3, so C. So the final answer for this question is C, number 4. Straight application on Suvat equations, knowing the conditions of these equations. Again, uniform acceleration and motion in a straight line. Thanks for watching and have a nice day.